Now, although it is possible for us to create Django fixtures for the database and then have Django migrate that data when we start the container, we're going to automate the process of building the database and seeding the data through Postgres database. Now, the setup that we're developing here is simply for simplicity, so that you can download any of the source code in this course, and you should be able to run just the one command, and everything should automatically be prepared and ready for you to then interact with the code or to extend or follow any of the tutorials in the course. So this is the workflow that we're building when the container starts. So first of all, Postgres is going to initialize first. It's going to then create the tables needed to build the category and product table as we've specified in our Django model. And then it's going to automatically populate those tables with data. So that's the first step. And then in the second step, the Django container starts. It runs make migrations on the models, but then we're going to perform a fake migration. So a fake migration in Django is useful when the database schema already matches the model definitions, and it will do because we're going to create the tables and populate the database, and we're going to follow the Django model to ensure that the model matches exactly what we create in our database. Now, it is of course important that we only use fake migrations if we're 100% sure the database schema matches what our Django models expect. And of course they will do in this case because we only have two simple tables. So when we run the fake command on our migration, Django simply skips running the actual migration code. So no tables are created and no schema is altered. However, Django still records the migration as applied. So it tells Django, you don't need to apply this migration in the future, it's already done. So that way we can continue working with Django as per usual. Okay, so let's start with the data. I've simply copied this into our AI coding partner, and I've asked for some data in a CSV format. And I've simply then created a new folder here called DB data, and then I've added that data into two corresponding files. If you've not seen CSV before, at the top here we have a header, which is optional, and you can see that each header item separated by commas identifies the corresponding data in each of these items in this list. So ID here equals 1, category, this is 1 here in this data, name, iPhone 13, and so on. So this is the data for our product and our category. If you don't want to make your own data, then download the source code connected to the first tutorial in this module. So next up, I've created an initialization file, initial.sql, and this file is going to be run when the Postgres container starts to build the database tables and then to load the data in. So again, we can use our AI coding partner to ask to translate our models into SQL. So it should look something like this for our category table. And then the SQL needed for our product table looks something like this. Right, so now we need to actually load our data into the tables. So for that, we can use copy. So let's take a look at that. So copy inventory category. So that's the name of the table. And then we go ahead and define the fields. And then we define where the data is going to come from. In this case, the category.csv. We define the delimiter. So that's just referring to the fact that the data is separated by commas, if we take a look. And then there is also a CSV header. It's just referring to the fact you will find a header at the top here and not to include that in the actual data that we insert into the table. So we're going to need to copy both the category and the product data. Now, what we need to remember here is that this will be running on the container. And we can see that we need to actually make the data available in the container so it can be inserted into the table. Right, so in the Postgres service, we now need to define some volumes. So I'm going to create two volumes here. One to actually run the initialization script. the init.sql, and then want to map the DB folder to our data folder in the container so that we can then go ahead and run our commands we specified. So here, notice there is a special entry point. Now this is a special location which Postgres looks for when it first initializes. So any scripts we put in that folder will automatically be run. So we simply place our initialization file inside of this folder on the container, so therefore it is run on the initialization stage. And then of course, like I said, we've mapped across our data to make that available so that we can insert it into our database. So let's just test to make sure that this works. So let's run docker compose up build, and that should then restart the containers, and hopefully the new information will be picked up and we would have created our new tables and inserted our data. Now, if we inspect our Postgres container, we're told that it skipped the initialization phase, so it didn't create our tables and data. And the reason for that is because of volumes. So what's likely happened is that when the Postgres container initially started, when we previously started it, it created a volume. And in that volume, it then created data related to initializing the database. So where we've just recycled the container, like we've just done here with the previous command we used, what's happened here is it's picked up the data in the volume and it thinks that the database has already been initialized. So we're going to need to remove all of the containers. And then in addition to that, we ought to also remove the volume. So once the green is removed, it's currently in use, deleting the containers, we can then go ahead and remove that too. So let's work through that process again. Now when we run docker compose up with build, it should restart the container and fully initialize the database. So when we go back into the container, we can see here that the database was created as per usual, and it's found information in the initialization step in our init.sql file. So it's created two tables and it's copied the data across. At this point, it does look successful. We can further inspect that by moving over to the console. Let's use PSQL. Let's specify the Postgres user and the database inventory that we're working with. And now we can use \DT to view the tables that have been created. So the last step now is to configure the fake migration so that Django doesn't try to migrate the tables from the models because the database has already been created. I've updated the commands now in the docker compose Django service. Let me briefly explain what's happening here. Right, so first of all, I want to make sure if the database has already been set up or not. So if I'm working with the container and restarting it, I simply want to make sure, well, does the database already exist? If it does exist, then I don't want to go through the process of migrating and fake migrations, etc., because it already exists. Everything is ready for us to just then continue and start the actual Django server. Now, if it is the first time we've created the containers and we're not just recycling the Django container, then we're going to run the else components here. So we're going to remove any initial migrations that might be there. Now that's making the assumption that there is only one migration. So that's a flaw of this design at the moment. So when we build a migration, we will find initial.py file will be created by Django. So we just want to remove that first, because this is potentially at this stage the first time we created our Django project in the container, because we've just restarted the whole containers. So we want to remove that if it exists, and then we're going to run migrate to just make sure that all the Django apps have been migrated. And then we're going to run make migrations to create the migration file for the inventory app. And then we go ahead and individually migrate the inventory app, but this time we use fake. So again, like I said, we aren't actually going to apply those migrations to the database, because the database has already been created, of course. Right, so once we've done that, I've also set up a new admin user so that we can easily, quickly enter the Django admin should we want to. So here the admin user and password is just going to be admin and admin, but of course you can just change that. Once that's done, we'll go ahead and start the Django service. Right, so our final test, can we restart all of the containers and then maybe navigate to the Django admin? So let's give this a go. So I'm going to remove the containers first. Once that's done, I'll remove any volumes, and then we'll start the containers and see if this works as intended. So let's start the containers. It looks like potentially we have an error in command. Just a little bit of indentation issues. So I just need to indent this across to the ports. So I'll go ahead now and run Docker Compose up again. It looks like the containers have started successfully. So all I need to do now is to go into my browser, go over to local 8000, open up admin, so /admin, and I should be able to now log in as admin, and I now need to register the models. So if you head over to inventory admin, just gone ahead and registered our 2 models. So now when you head back into admin and refresh, we can now view the category and the product's data. So with that in place, we should now be able to download any of the source code connected to this project, quickly start it with one command, and have everything ready and prepared for you to follow along or to extend the code.